Okay,
Sour stars.
8.3. We're gonna talk about solving linear systems with back substitution with Gaussian elimination.
What substitution? Back substitution.
Back substitution is simple, you've done it. You just don't know the terminology. If I have x minus 2y plus 3z equals 9y plus 4z equals 7 and z equals 2. How do you think you want to start solving this? Plug what? Plug z in. Yeah, we're gonna plug z into
Oh, that's what we just, we got
to the green, yeah, to the green equation. So that I can get y, and then we'll plug y and z into the red equation so I can get x. Back substitution.
Y equals 1.
So we get y plus 4 times 2 equals 7. So we get y plus 8 equals 7, so y equals -1. Yes? Now we plug all this into the red equation. You get x minus 2 times -1 plus 3 times 2 equals 9. So we get x plus 2 plus 6 equals 9. 6 and 2 is 8, x equals 1. So then when we write our solution, we write it x, y, z. So 1, -1, 2, x, y, z. Back substitution. Pretty simple. Okay. Gaussian elimination we're going to do on this one and that one. And we're going to take a look at what this means. So for Gaussian elimination, you have to first interchange two equations. Then you multiply one of the equations by a non-zero constant, and then you add a multiple of one equation to another equation. Okay? So we're going to walk our way through this pretty simply. Okay? First, adding the first equation to the second equation produces a new second equation. So we're going to take the first equation and the second equation, add them together. So when I take the first equation and second equation and add them together, x cancels out, yes? And then you just get y plus 4z equals 9, correct? Y plus 4z equals 9, okay? So I get a whole new equation. I'm going to then drop down the other two equations I have and keep these the way they are. Thank God for different colors. Okay. So, my first step is complete. I interchanged two equations. I added two equations together. The second step is to multiply one of the equations by a non-zero constant. Okay? So I'm going to take, oh wait. Let's think about this. I need to add still. I need to add so that I get it to y and z, two equations to y and z so that I can solve for y and plug in. What? You mean this? It's supposed to be equal to 7. Thanks.
Corona.
Thank you.
Good job, Morgan.
Good, Morgan. Okay, it's supposed to be equal to 7. So now we're going to take the top equation and the bottom equation. Because we use the top equation with the middle equation, we have to use the top equation with the bottom equation now. Okay? Add them together. The problem is if I add these together, nothing's going to get canceled out, correct? So what do I need to do to the top in order to cancel out that x? Multiply by -2 is fine, yes. So -2x and 2x cancel. Then I get 4y and -5y, which gives you what? -y, yes. Okay. And then I get 6z and 5, or -6z and 5z, so I get -z. And then I get -18 and +17, so I get -1, yes? So I have these equations now. I'm gonna rewrite this down for us, so we can see.
He got corona.
That was more good.
She got corona.
He said he.
Okay, so now I have these three equations to work with. I'm gonna keep my green equation in the same form that it originally was in, so I have x minus 2y plus 3z equals 9. I have y plus 4z equals 7. I have -y minus z equals equals -1, okay?
Give it to her. She
And
can come
because of that, now the y's eliminate by themselves, yes? Okay, so I keep this green equation still, I'm just gonna work over here where I have a little bit more room.
I hope you get Corona.
Okay, when I add these together, okay, I'm gonna end up getting what, what z equals. So I add these together, y cancels out, 4z plus, -z gives me 3z, and 7 plus -1 gives me 6. 3z equals -6 means z equals, 3z equals 6 means z equals 2. So now, from there, I use back substitution and work my way back up. Plug 2 in to this equation, because it's the, and then I can solve for y. Y plus 8 equals 7, y equals -1. Plug z and y into my green equation, and I can solve from there. So x minus 2 times -1 plus 3 times 2 equals
What are you talking about, boy?
9. X plus 3
Oh, Jen.
plus 6 equals 9. Is that right?
Kill me something, slave message.
What is it? What you talking about, boy?
No, that's a z.
Yeah.
Sorry, thank you.
No, you plug, no, you plug the.
Wait, no.
That's wild.
That was
That's
right.
just
I was right, the other one. Why is it plus
It's not,
That means
because
you
I
have
did
to
2
beat
plus
Macedonia
1 in my
to
head,
get
that's
extra.
fine. So then x equals
I wouldn't be
1.
playing people for this.
Which is exactly how we did it over here when they allowed us to use back substitution. So you get 1, -1, 2.
This just takes a long time to practice.
So I beat my master in 2K, he gonna let me go.
So when they don't give us what one of the variables used equal, you have to use Gaussian to get to where you need to go. But yet I still get the same answer, 1 -1, which is why I know I did right. Okay, 2 more and then we'll be done. How would you want to start this new set? X minus 3y plus z equals 1, 2x minus y minus 2z equals 2, and x plus 2y minus 3z equals -1. What variable do you want to get rid of?
Y.
X.
X. X is the easiest because the blue and the red just have x already by themselves, so I only have to multiply one equation. If we change these, like this equation, and add them together, that means I need to multiply this top one by -2, correct? So if I multiply it by -2, I get -2x plus 2x, which is 0. I get, I'm gonna rewrite this equation real quick.
Try to give me a piece of that Nutri-Grain bar.
I get 6y minus y, so 5y. I get -2z and I get -2z added together, so -2z plus -2z is -4z.
Yeah.
And I get -2 added to 2, so you get
I'll give you the light skin eyes right
0. Now, in order to add it to the red equation, I don't have to multiply it by anything, so x minus x is 0, correct?
Yeah.
-3y plus 2y gives me y, -y. Z minus -3z gives me -4z, and 1 minus -1 gives me 2. Okay? So I have some other equations going on.
Appreciate you, cuz.
Now, from there, what should I do?
Crunch.
Something doesn't seem right.
I'm a DM LeBron to see if he gonna pay for my
Oh, this
college.
should be positive, this should be -5.
Come on, bro, everybody called you to pay for mine, nigga.
Okay, what do I do there?
Help a nigga out.
Add these, and they cancel each other out, yes? Well, they give me this, when I add
Give
them,
me accurate.
I get 0 equals 2, what's wrong with that?
You can't do that.
It's not a true solution, so this is no solution in this case, okay?
Yay, we
So
love
we
no
can get a
solution.
solution, we can have no
That's a lot
solution,
of work.
Man, we realized I could just wrote no solution as a guess and still got it right though.
Okay, now over here, let's take a look at this one. This one's a little different because they're missing different variables from different things. So what do you think we need to do?
Well,
Like this has all three variables, but this just has a y and a z, and this just has an x and a y, so I can't cancel
Substitute,
stuff out.
substitute.
Okay, how do you wanna substitute it, Tyler?
That the one with the negative x plus 2y. You wanna add x to the other side.
why don't you put the red one in the blue
Yeah,
one
what about the
first?
red and the blue?
That's what I mean.
Okay.
You wanna put the red into the blue is what you're saying?
I wanna put the blue into the red.
Oh, okay.
I want a challenge.
Look.
Like,
You can have that shot.
Of course, say no challenges today, just do it as simple as possible. Okay, let's change this into y equals, yes? If I change this, ooh,
Alex,
if
I
I
like
change
that
it
sweater.
into y equals, it gives me y equals z,
What are you looking at?
correct?
Turn around. No. Oh my gosh, you're so annoying.
He gonna catch you on the stairwell.
What's wrong with you guys?
I swear, Brett. When I see Cora at UC next year, it's over. I'm about to roast you.
I'm gonna tell my friend to believe.
Cora gonna be
Um, Okay,
dropping the bag.
that's not gonna help us, because if we plug this in down here, I'm just gonna get a z in there instead. So let's add this and this together to get rid of x. What about that? So if I add these together, okay, I have the top equation that stays the same, x plus y minus 3z
It's
equals
not how you
negative
feel
1.
at church. I just be looking.
My red equation stays the same,
listening to shit.
Tyler.
Oh, my fault.
My
bad,
blue
Jesus.
equation changes, x's will eliminate, yes, and then add it together, you get 3y, and then minus 3z equals 0, yes?
Yeah.
Okay, when I add those together. That helps me out a little bit, because now, if I change this into y equals, I can substitute it in here and I'll only have z's. Okay, so I'm gonna take that y equals z and plug it into this blue equation, so that says 3 times z minus 3z equals 0. So 3z minus 3z equals 0, so 0 equals 0. What does that mean?
Oh,
Yeah, infinite solutions.
Yeah.
So this is what you are going to work on today, okay? So you can have one solution, you can have no solution, you can have infinite solution, but you're gonna use Gaussian elimination.
What's down on the job?